Module 6, Lesson 3 deals with writing and solving two-step equations in the form of px plus q equals r. Now the last lesson we did, we actually solved these things, but now we get to write them first and then solve them. The objective says students will write and solve two-step equations in the form of px plus q equals r. The suggested pacing says this is likely going to be a 2-day lesson, so let's get started and see what they have in store for us. There are many types of skiing, such as cross-country skiing, downhill, or freestyle. Downhill skiing is the most popular. As the name implies, it consists of skiing down a mountain. No matter the type of skiing you prefer, being part of a school ski club will allow you to have plenty of chance. Yeah, like we're going to have snow skiing clubs up down here in Gulf Shores, Alabama. Suppose you know the cost to join the ski club. If you pay a deposit and plan to save every week to pay for the cost, then you can determine how long it will take you to save the rest of the money. And here we can watch a video of somebody snow skiing. Looks like a good way to break your neck to me. Anyhow, how to do these things? Well, that's going to be part of what we learn in this lesson. Now our inquiry question is, how can a bar diagram help you to solve these kinds of problems? Miranda bought 2 large postcards and 4 small postcards at a souvenir shop. Each small postcard cost her 50 cents. Meanwhile, Miranda spent a total of $5 on the postcards. What is the cost of 1 large postcard? Be able to explain your strategy for solving this problem. To work it, we're going to do this as a bar diagram, and we're going to recognize what we know. First, we know that she bought 2 large postcards. Let's highlight that, and 4 small postcards, and together those cost $5. We also know that the small postcards are going to be 50 cents each, so we're going to highlight that as well. We're going to make ourselves a bar diagram to represent this information, and it's going to look something like this. First, we're going to start off with the entire bar. From there, we need to take and recognize that the bar represents 2 large postcards, and it represents 4 small postcards. Good so far? From there, we're going to recognize the fact that the total cost of the bar, all the postcards, is going to be $5. And the last thing we have to look at is the fact that each one of those small postcards, those cost 50 cents each. And what we're trying to find out is going to be the cost of 1 single large postcard. Now, if we wanted to take and write an equation to represent this data, it's really very easy to do. All we have to do is say 2 times some unknown number. Do we have something to represent an unknown number? Sure we do. That's going to be x. So 2 times x plus, what's 4 times 50? That's going to be $2. Or 4 times 50 cents will be $2. So 2 times x plus $4. That is going to equal the total of $5 that they gave us for the whole postcard set. So you can see here, they're going to take that. They're going to say that instead of x, they use p. So 2 times p plus $2 again, because remember, 4 postcards at 50 cents a piece. That was going to be your $2, and that equaled the total of $5. So that part checks. To solve for the cost of 1 postcard, well, we're not really going to work it out right now, but we'd subtract 2 from both sides, and that would be 5 minus 2 would leave you 3. And then when you divided 3 on both sides, you would find out that each one of those large postcards cost $1.50 each. We're going to get more into how we solve those later, but this is also the same thing we did in yesterday's lesson, how we solve them. Some real-world situations can be modeled by 2-step equations. Consider the following. A caterer is preparing a dinner party. She charges an initial fee of $16. That's $16 just to do business with her, which is dirt cheap for a caterer. And $8.25 per person after that. How many people can attend the dinner party that costs $131.50? So first thing we need to do is take and describe the mathematics in words. The initial fee plus the $8.25 is going to equal to the $135 total. From there, we need to figure out what our variable is, and P is going to be the number of people that can attend the party. And from there, we need to translate all that into an algebraic expression. So the initial fee was $16 plus the $8.25 times the number of people. That equaled the total of $131.50. So here you've taken a sentence, of a real-world situation, and converted it into an algebraic expression. New problem. Toya had her birthday at the movies. It cost $27 for pizza and $8.50 per friend for the movie tickets. Obviously, they went to a matinee. Write and solve an equation to determine how many friends Toya had at her party if she spent $78. Well, we need to start breaking this down into the things that we know. We're going to start off, I suspect, by writing it in words, just like they've been showing us, and then we'll be moving forward from there. So in words, we know that we have the cost of the pizza plus $8.50 for every friend, the cost of the friends, times the number of friends, and that the total all added up to equal $78. From there, we can come up with our variable. They let n equal the number of friends. I probably would have used f for friends, but in the end, that variable really doesn't matter. And what are we going to do from there? Well, we're going to convert all that information into a mathematical expression, maybe. Oh no, they want us to use a bar diagram. So the bar diagram is going to show that the total cost, the $78, equaled the $27 for the pizza plus the $8.50 times the number of friends. And from there, they finally got around to doing an equation. The $27 for the pizza plus the $8.50 times the number of friends equaled the total of $78. But part B of this problem says they want us to solve it. We can't just take and throw down answers without being able to solve them. So we're going to start off by, what's the final goal of an equation? Isolating the variable. The first thing we undo is addition and subtraction. 27 is adding itself to n, not because of this plus sign, but because of the invisible plus sign in front of it. These 27s on the left are going to zero each other out, leaving you, and I put a line through that if I were you, leaving you $8.50 in on the left, and on the right we're going to have 78 minus 27. That's going to equal to 51. From there, we're going to undo multiplication and division by dividing $8.50 on both sides. The 850s on the left are going to divide out, leaving a 1. You can put a 1 or a line through them. And then on the left-hand side, well, now we're going to have to do some real grunt work. So we're going to come over and do, let's find some clean real estate, 51 divided by $8.50. Let me make sure those are the correct numbers there. It is. I'm going to bounce the decimal until it hits the wall. 1, 2. And then I'm going to move the decimal inside the house the same number of places to the right. 1, 2. And I'm going to annex zeros as needed. Now there is another way to approach this problem because quite frankly I don't want to have to divide 85 into anything here. So instead, what I'm going to see 850 into anything here. So instead, let me see there, I got it working again. I'm going to get rid of the zeros on the ends of here, and that's going to end up giving me 85 divided into 510. Best guess is going to go into 510. Well, 80 goes into 500 6 times because that'd be 48. So let's try 6, see what happens. 6 times 5, that's going to end up being 30. 6 times 8 is going to be 48, plus 3 is going to be 51. So the answer is going to end up being 6. We'll jump back over to our problem. N is equal to 6. That means she had only 6 friends she was able to invite to the movie with her. And now it's going to be your turn. Pause the video, create yourself an equation based off of this information, and then solve your equation. Actually, they don't even want you to solve it. Yeah, they do. Right down there, they want you to solve it. Create your equation and then solve it. Cameron wants to download some movies, and each one costs $14.50. So we know that $14.50 times some number of movies is going to be one of our pieces. And I'm just going to take and highlight that part right here. And an ebook, and that means one ebook that's going to cost a total of $22.50. So that's not being multiplied by anything because it's and, which means one. And he has a total of $66. Going back to the question that they gave us, they said write and solve an equation that can be used to find the number of movies he can download. So I did that. I've got my $14.50 plus $22.50 is equal to 66, and that means that I've got B is going to be my correct answer, and that checks. And then now we're going to have to solve it. So I'm going to jump back over to here. I'm going to start off by isolating the variable on doing addition and subtraction by subtracting $22.50 from both sides. That of course means I'm going to have to annex some zeros here. These are going to zero out, leaving me 14.5 m. Yes, I know it's a zero, but it has no real value. Is equal to, and then we're going to take and, oops, that should have been zeros here. Subtract here, that's going to become a 0. Do some borrowing. 10 minus 5 is going to be 5. Decimal comes down. 5 minus 2 is 3. 6 minus 2 is 4. So that gives us $43.50. Now we're going to divide both sides by the 14.5. When you do that, these divide out becoming 1. 1 times m is going to be m. And we're going to have to find a place to do some grunt work. 43.5 divided by 14.5. Bounce and bounce. Decimal goes up. I'm going to try, 3. 3 times 5 is 15. 3 times 4 is going to be 12. Plus 1 is going to be 13. 3 times 1 is going to be 3. Plus 1 is going to be 4. Look at that. M is equal to 3. Got the right answer on my first try. Jump back over here. Put in the 3. And the answer checks. We're going to stop here working on this video. Come back to watch part 2 so you can get the rest of your lesson.